This is Honors Geometry, Lesson 8.4, Properties of Rhombuses, Rectangles, and Squares. So we were studying parallelograms, and now we're going to talk about three special parallelograms. So a rhombus, a rectangle, and a square are all parallelograms. So all of the rules we learned for a parallelogram apply to the rhombus, the rectangle, and the square. If we take our parallelogram and make it have four congruent sides, it turns it into a rhombus. So it's sort of like a tilted square. If we take our parallelogram and straighten it out so it now has four right angles, we can call it a rectangle. And the last one, if it has four congruent sides and four right angles, it's a square. You know that, right? All right. The corollary to it says any quadrilateral that has four congruent sides has to be a rhombus. So we also know that our square would be a rhombus because it also has four congruent sides. Okay, if it has four right angles, it has to be a rectangle. And if it's both a rhombus and a rectangle, we call it a square. All right, let's talk about some rules. First one, in a rhombus, the diagonals are perpendicular. Why do we care? Because now that gives us right triangles. Right triangles we can use Pythagorean theorem or we can use the trig ratios. So in a rhombus, the diagonals are perpendicular. They form four right angles. In a rhombus, the diagonals bisect the angles. That wasn't true in our parallelogram, but it is true in a rhombus. The diagonals bisect the angles. And the last one, in a rectangle, the diagonals are congruent. It wasn't true in a parallelogram. We got a short one and a long one. But in a rectangle, when you straighten it out, you get two congruent diagonals. All right, I thought we'd try one of each. We'll do one rectangle, one rhombus, one square. So they give us two pieces of information. They tell us the diagonal is 10 units long, and they give us one acute angle is 34. So the first thing I'm thinking is that we have a 90-degree angle. So I'm going to take that 90-degree angle minus my 34. I can see this is 56. Alternate interior angles, I'm going to carry this 34 up here. I'm going to carry this 56 over here. But we also know the diagonals are congruent and they bisect each other. So we know we have an isosceles triangle. So if this is 34, this angle has to be 34. If this is 34, we know this is 34. And the same thing here. If this is 56, we know this angle is 56. If this is 56, this is 56. So far, so good. Now, we know all triangles have 180 degrees. So I'm going to take 34 plus 34. That gives me 68. I'm going to take 180 minus 68. And it looks like this angle here is 112, which means this angle is 112. And then I'm going to subtract from 180. I have a linear pair there, so I'm going to subtract that from 180. And it looks like these angles, are 68. All right, so we found all the angles. Now, I know the diagonals are 10. If one diagonal is 10, I know the other one has to be 10 also. Now I can get the sides. We're going to use good old SOHCAHTOA. So we're given the diagonal is 10. We're given this acute angle is 34. So if we go back to SOHCAHTOA, I'm looking for opposite. I have hypotenuse. Looks like we're going to start with sine. So I'm going to say sine of 34 equals opposite over hypotenuse. I'm going to cross multiply sine of 34 times 10. And I can see that side is 5.59. We're going to call it 6. Or 5.6. Okay, so if we know this side is 5.6, we know that this side is also 5.6. This point, I think I'm going to go ahead and just use cosine. It's super easy. So from the 34, this is adjacent. I'm going to use that hypotenuse again. Adjacent hypotenuse tells us we use cosine, so I'm going to say cosine of 34 equals adjacent over hypotenuse. So back to my calculator, I'm going to punch in cosine of 34 times 10, and it looks like our other side is 8.29. We're going to call it 8.3. Okay, so just being given one diagonal and one acute angle, we were able to find every other piece of that rectangle. Let's do the same thing with a rhombus. Okay, so we're given this is a rhombus, and we're given that this piece is half of this one diagonal is 8 units. So right away I know the other half is 8. Let's use our alternate interior angles. We can carry this down to here. And then again, what's special about a rhombus, the diagonals bisect the angles. So if this half is 53, I know this half is 53, and these are both 53. The other thing special about a rhombus is the diagonals are perpendicular. So I know I have 4 right angles. So I'm going to go ahead and take 90 plus 53. I'm going to subtract that from 180. Oops, that's about 37. So I know that this angle is 37, which makes this angle 37, which makes this angle 37, and this angle 37. Piece of cake. All right, let's go ahead and find the sides. So I'm going to pull out one of these triangles. Change color so we can see a little bit better. I'm going to go ahead and pull this triangle out. So what we know this angle is 53. We know this angle is 37. And we know this length of this segment is 8. We were given that this was 8 and they're bisecting each other. So I'm going to go ahead and find the hypotenuse. That'll give us the length of the side, and all 4 sides are congruent. So from the 37, I'm going to go ahead and use my adjacent, and we're looking for hypotenuse. If we go back to SOHCAHTOA, adjacent hypotenuse tells us we're going to use cosine. Cosine of 37 equals adjacent, which is 8, over hypotenuse, which is what we're looking for. Cross multiply. 7. Divide by cosine of 37. So I'm going to take 8 divided by cosine of 37. And it looks like our side is 10. So that's our hypotenuse is 10, which was right here. So we know that all 4 sides are congruent, so all 4 sides are 10. And all we need now is the other diagonal. So from the 37, let's call that opposite. We now know the hypotenuse is 10, or we could just use the adjacent, which is given. I'm going to go ahead and use the one that's given. So opposite adjacent, that's tangent. So I'm going to say tangent of a 37-degree angle equals opposite over adjacent. We're going to cross multiply tangent of 37 times 8, and it looks like that's 6. And maybe you remember the 6, 8, 10 triangle. That's one of our Pythagorean triples. So we know this is 6, which makes this 6, and we did it again. We solved this whole rhombus. Let's do one more with a square. All right, a square, they didn't have to give us much. They gave us that LK, half of one of the diagonals is 1 unit. So we know that all of these diagonals are 1 unit long. We also know that all the angles are right angles. And because a square is a rhombus, we take that 90 and we cut it into 2 45s. So we're looking at a bunch of 45, 45, 90 triangles. And again, the diagonals are perpendicular because a square is a rhombus, and we know the diagonals are perpendicular. So what we're looking at is a 45, 45, 90 triangle where the sides are 1, and we know that the shortcut is whatever the side lengths are, the hypotenuse is that times the square root of 2. So we can just say it's good old square root of 2. So that means all of the side lengths are the square root of 2. And easy as that, we've solved the square. Go ahead and try the practice problems. Let me know if you have any questions. Thank you.